The skin is an intricate organ consisting of multiple layers. The epidermis forms an elastic protective outer layer. The lower layer, the dermis, contains sweat glands, hair follicles, and sebaceous glands. The subcutaneous layer consists of connective tissue and fat. This arrangement allows the skin to perform numerous essential roles, including protecting against injury and infections, reducing water loss, and regulating temperature. A partial or full thickness wound damages the epidermis and dermis, disrupting within those layers a gel-like substance called the extracellular matrix, or ECM. The ECM is a three-dimensional scaffold to which cells attach to form tissues. Restoration of the ECM is a critical process in wound healing and occurs through a coordinated series of events, starting with hemostasis, during which a blood clot forms. After the formation of a blood clot, white blood cells move into the wound bed to begin the inflammatory phase of wound healing. During the inflammatory phase, monocytes and other cells associated with the immune response remove bacteria, debris, and damaged tissue from the wound. Towards the end of the inflammatory phase, ECM proteins, including vitronectin, are deposited into the wound. These sticky proteins play a key role in the initial stages of wound healing by binding to the wound bed and combining to form a temporary scaffold to which skin cells can attach. With the support of growth factors, such as insulin-like growth factor 1 or IGF-1, these anchored cells can migrate and proliferate over the surface of the wound and begin wound closure. During the migration and proliferation stage of healing, the attached skin cells rebuild the disrupted ECM. They also alter the ECM's composition, helping to guide wound healing from this initial stage through to tissue maturation. Unfortunately, healing sometimes stalls and wounds remain in the inflammatory phase for a long time. As a result, processes intended to fight infection and remove debris further damage the ECM. For example, high levels of enzymes that degrade protein, a normal inflammatory phase response, damage the temporary ECM that initiates healing. Skin cells cannot attach to this disrupted ECM. As a consequence, healing slows or halts, resulting in chronic and often painful wounds. Healing can be reinstated in these wounds by replacing the damaged matrix with a substitute that promotes healing. VitroGro ECM is a novel synthetic matrix protein that consists of an ECM peptide combined with a growth factor that's been specifically designed to restore healing in chronic wounds. VitroGro ECM contains a portion of the adhesive vitronectin protein, which binds to the wound bed, providing sites for skin cell attachment. VitroGro ECM also contains IGF-1 that supports the migration and proliferation of attached cells. This design targets the initial stages of wound healing that is often stalled in chronic wounds, promoting healing by replacing the damaged scaffold and providing sites for cell attachment that restores the anchorage-dependent migration and proliferation required for healing. VitroGro ECM is applied topically to the prepared wound. Once applied, the adhesive VitroGro matrix protein binds rapidly to the wound bed, replacing the damaged ECM, thereby providing a scaffold that supports the attachment of skin cells. The IGF-1 component of VitroGro ECM supports the migration and proliferation of the attached skin cells. This restores the wound healing process. During this process, the skin cells, predominantly fibroblasts, produce new ECM proteins. The increasing number of skin cells in the wound produces a new healthy ECM. This restores the damaged dermis, which in turn forms granulation tissue, a critical step in wound healing. The granulation tissue promotes the migration of epithelial cells onto the wound bed, reducing the size of the wound. VitroGro ECM is applied once weekly in conjunction with the standard of care. These weekly applications tip the balance from chronicity towards normal healing, further reducing the size of the wound while helping to reduce pain. The wound closes and the tissues mature normally to leave healthy and functional skin. So, VitroGro ECM breaks the cycle of chronicity that is associated with the breakdown of the normal healing in stalled wounds.